Hi guys, welcome again to the AD course. Today gonna be talking about local estimates. So let's start. What is local estimate? As some of you guys I think have watched my last about data types. So we talk about numerical data types and what it represents in a given data set. And as you got as you guys may notice in the exercise we passed to you guys, it's very hard to analyze a column for all the data, for all numerical data that we have in our data set. That's because you have too many observations and that can be exhausted to analyze one by one. And because of that, we use statistics to analyze where most of our data is located, so we can extract valuable insights without going to every data point that we have in our data set. So I think some of you guys may know the mean estimates. It is the most basic estimate of allocation and is also called the average, depending on the country that you learned. And the mean basically is the sum of all the values divided by the number of values that we have in our data or in our set. For example, we have here an example of a set containing the numbers 3, 5, 1, and 2. So to extract the mean of this set, we must sum all these values. So we must sum 3 to 5 to 1 to 2 and divide by the number of items we have in our set. So we have 1, 2, 3, 4 items. So we divide all that. So we come to a conclusion of 11 to 4. And that's basically the mean for this set, for this example. And describe the mean in this formula. It can be represented as x with this bar on top, and we can see that is the sum varying from I to n, where I is equal to 0, it's the first element of our set, and the number of items we have in our set, okay, that divide by n. So that's the definition of mean, and it's very used in data science to analyze where most of our data is located. Okay, moving forward, we also have the weighted mean, and it is another type of mean which you calculate by multiply each data value, as we saw. So we have the items here in our set 3, 5, 1, 2. So we multiply each one of them by some weight, and that weight should be described or given depending on the problem that you're trying to solve, and divide the sum by the sum of the weights you are given. So I mean, some of the values are intrinsically more variable than others, and highly variable observations are given a lower weight. So what does that mean? Imagine you have data collect from multiple sensors, and we have I don't know, maybe some bad data that were collected wrong, and we want to calculate the mean for all these records, and we know that we have bad data, and we decide to calculate the mean, but not the traditional mean, the weighted mean, and by doing this, we must given lower weight, okay, to the wrong values that were collected by our sensors, and lower and a higher weight to those records that were collected successfully, and we have any problem with that. So here's the formula we have for the weighted mean. Is represented by x and w, okay, and it is basically the sum varying from 1 equals to 1 to n, and here we have the x, that is the value of our data set, multiplied by the weight given for each item, okay, and all of this is divided by the sum of all the weights we have for our elements in our data set. Okay, so let's move on. We also have the median estimate to analyze, summarize our data, and the median differentiates from the mean. Okay, we have mean here, but it's median, right? Let me just correct it. Median, and the median is basically the middle number on a sorted list of the data. And I mean, if there's an even number of data values, will be the average of the two values that divide the sorted data in upper and lower halves. For example, we have here the previous example where we have a set with 4 elements, 4 numbers. So we have 3, 5, 1, and 2. And if we want to get the median for the set, we would see that we have a list that is even. So we get the two values that divide the set into lower and upper halves. So here we have 3 as the lower half, okay, and 2 as the upper. And the values that divide the set is 5 and 1. So we get these values and get the average of both. So we will have 5 plus 1 divided by 2. It would be equals to 3. So we would find that 3 is the median for this example. And right here we have a image showing the difference between the median and the average or the mean. We see here the list of house prices, and the list have prices varying from $100,000 to $3 million, and we can see that calculating the median and the average or the mean, we have different values, right? So here we have the average or the mean resulting in almost $500,000, and the median actually is resulting for 105,000. And we can see the price, the average price of a house is greatly affected by these three values that we have, right? So we have the houses 8, 9, and 10 that has values that diverge a lot from the initial 7 house, and because of the three houses, the price of the other is greatly affected. But we can see that the median is really not affected by these outliers, these values. This house is too expensive, and we get only the central value for this house, and you can see that we can represent it well with the median instead of the mean in this example. And actually this is a very important topic, because if we would give a chance to analyze, maybe we would consider these three last houses as outliers, because its value diverge a lot from the majority of the houses. And an outlier is basically any value that is very distant from the other values in a data set. They are often the result of data errors, often, okay, and such as mixing of different units or bad reads from a sensor. So we have an example here showing the number of messages exchanged in 1 month. Okay, so we have here 14 data points, right? Measuring the number of messages exchanged by the users, and we can see that most of our data lies between 3,000 and 5,000. So here is where most of our data is located, and as you guys can see, actually 13 data point is located here, but 1 out of 14 is located here near the 10,000 messages exchanged. That would suggest that this value is an outlier, because it's very distant, right, from the other values in our data set. And that's only the first analysis that we do. Of course, we have to do when we are working with outliers. We have to do a lot of analysis, not only in our data set, but in the outliers itself. I'm going to give to you guys a class about outliers, how we can identify which technique we use, right, in our work, and how we're going to deal with them in our data sets. Okay. So that's it for this lecture, guys. See you the next one.